We're starting. Actually, it used to be the chapter used to be called quadratics, and we did factoring, and then we did solving, and it was like at least 7, maybe 8, 9, or 10 lessons long, and then the test was super long. Anyway, long story short, this year I separated it. So we have a factoring chapter, and the next we'll have a solving chapter. So I'm hoping this factoring chapter, I'm hoping at least these first couple lessons are review from Algebra 1. But again, factoring is one of those things that some people are really good at it and you're over it. You already know how to do it from Algebra 1 and you're good. Other students really struggle with it and they're not very good at it and they need that extra help. So if you are the former, where you're really super good at it, just don't ever complain about math that's too easy. That's one thing I learned very quickly in my mathematical career. There will be a couple things, just like the last chapter, there will be a couple things that are new this year that aren't from last year. So make sure you're paying attention because that'll really help. The other thing I do, most of the time, textbooks and most of the time teachers, when they start factoring, the first thing they do is they do a trinomial factoring where there's not a number in front. So if you glance ahead, since you guys have seen this before, this is a trinomial. It has 3 terms. That's why it's called a trinomial. It's called a quadratic because it's a degree of 2. I don't remember from a long time to go over all those things or not. But there's a number in front. That's how I like to start. Tomorrow, or not tomorrow, so must be Tuesday next week, we'll actually get into the easier stuff a little bit quicker. It won't take do it this way is because a lot of students learn how to do that shortcut, and then the problem is when they get to these problems, it's not that they're that much harder, it's just that you can't do that shortcut, and a lot of students think you can. So I would rather teach it to you guys the harder way first, how to do it the long way, because that works on all of them. Even if you forget the shortcut, you can do it this way and it'll work. But it's probably indifferent, 6 in one hand, half a dozen in the other. But I'm going to try this year where I do the harder one first. Because again, the biggest thing is students go too quickly and they try to use the shortcut where they can't. Start with the basics. What is a factor? So a factor, an example, sorry. A factor of b, so just b is a random number, is if b over a is a whole number. So a is a factor of b if you take b divided by a and you get a whole number. So if I have 100, 10 is a factor of 100 because 100 divided by 10 is a whole number. But 3 is not a factor of 10, or sorry, 3 is not a factor of 100 because 100 divided by 3 is some decimal. So I think you guys know that already, but again, sometimes I like to try to get back to those very basic definitions. I think that helps. But again, if you take 2 numbers and divide them, that's what it says, the next one. If you divide 2 numbers and they get you a whole number, the smaller one's a factor of a bigger one. If you take, again, b divided by a, if that's a whole number, then a is a factor of b. So, quick example, because sometimes you guys know this about me by now, but I think definitions are really nice, but I think trying to do numbers and then write it out in a paragraph is kind of hard to grasp. So I think some examples really make it a lot easier to understand. 8 is a factor of 24, and the reason is because 24 divided by 8 is 3. You get a whole number, no decimals, no fractions, everything's good in the world. 8 is not a factor, 8's not a factor of 36. 36 divided by 8 is 4.5. You did not get a whole number. You have a decimal or a fraction, so 8 is not a factor of 36. So the first thing we're going to do is I just want the factor pairs, that's what I call them. The factor pairs in the is all the other problems we do today. I'm going to make a list of all the numbers together to get them. Now I call them pairs because obviously they come in pairs. So 1 times 32 is 32. Pair. What about 2? 2 times 16 is 32. So 2. What about if you're ever not sure? And when I say not sure, I mean if you're ever not 100% definitely, absolutely sure that something's a factor, put it in your calculator. 32 divided by 3 is a decimal, so 3 is not a factor. What about 4? We have 4 times 8 is 32. What about 5? Well, again, hopefully 5 is pretty obvious, but if not, 32 divided by 5 is a decimal. You can move on. What about 6? 32 divided by 6 is a decimal. You can move on. What about 7? 32 divided by 7 a decimal, you can move on. So it seems like you're going to do this forever and ever. It seems like it's going to take you forever to go from 1 to 32 and try every single number to see it's a factor. However, I've got a little shortcut for this. If you do it the way I'm doing it over here, where you kind of list those, the way we'll do it for the other problems, I'll put a little bracket. But if you list them in order, so 1 and 32, 2 and 16, 4 and 8, you keep trying numbers until once you have a number that you're trying, you already have on the right-hand side, you can stop. So this one, we didn't even have to have half numbers. We go through 1 through 16. Once you go through 1 through 8, we already have 8, so we can stop. No other numbers are going to work. 9 is certainly not going to work, because if it would have already showed up by now. 10 is not going to work. If it would have, it would have showed up by now. So that's one of the reasons I like doing these pairs. Some people are really good at this, where it takes them like 2 seconds, they list them all out. If you're like me, I always forgot. There's always one that I forgot, and it always seemed like that was the one that was the important one that you could use. So again, I go through it step by step, methodically like that. I try 1, 2, 3, 4, 5, 6, 7, and then 8. Well, again, 8 worked because it's already on there, 8 and 4. Once you get to that number that's on the right-hand side, you can quit. Do number 18. Again, to set it up this way, but I do a little bracket. You'll see me do that with the other factoring problems. I'll give you a minute this, then we'll move on to good stuff. Any questions on that before we go on? I'm hoping that's not that terrible of a concept, but that it comes into play a lot today. So make sure we know that. Is everybody good? We're also going to mix that up a little bit. We'll do ones with negative numbers. It's not going to be too bad. You'll see when we do examples like that. But again, I could almost say that the core of these factoring problems really comes down to that. Okay, per usual, I gave you these tips. With these tips, I don't have any of them for the shortcut, because the whole reason it's a shortcut is if you know how to do it, you can use it, but you can always do it the long way. Now, again, we'll talk about that shortcut later. Don't try to do the shortcut today, because it's not going to work. So this style of factoring, it's hard because I like to stay consistent with all the other people. We call this divide bottoms up. I don't call that because like that. In algebra 1, if you that's what we're doing. So if you remember divide slide bottoms up, that's what we're doing. I always call the X factor or the X box factoring. Really, ultimately, the way I do it is the same way Algebra 1 does it. The only difference is I think I maybe set it up at the very beginning. I think my first step with that X is a little bit different, but I think that X is very, very useful and very important. The next tip that I will give you, and we'll talk about this more in a bit, make sure you keep track of positives and negatives. That's the hard part of this. A lot of people, when they have a negative, they just forget something and they make that little mistake, and that makes all the difference. So really be conscious about keeping track of your positive and negatives. Okay, so first and foremost, this is how they represent a quadratic. When we do the quadratic formula, it's A, B, and C. Those are the numbers that go in the quadratic formula. When we try to find the axis of symmetry, it's the A and B from here. When we try to find this is the A, B, and C. So it's always, the A always goes with the X squared, the B always goes with the X, the C is always the constant. It's in order. The A comes first, the B comes second, the C comes third. But you're going to have to remember that really the main rule is A goes with the X squared, B goes with the X, and C doesn't. Because without fail, we'll talk about this later, but if you have like 3x squared plus 5, some people think that 5 is B because it's the second number. Actually, it's the C because it's all by itself. Anyways. So the first step you're going to do, I know this sounds confusing. All the A's that I write down and the A, B, and C are all referring to these numbers. Notice there's part. You're not subbing in X squared anywhere. I mean, I guess there's an X out here. I'm not subbing anything into that. So draw this X. X is the first number times the last number. A, C, every time. Again, we'll talk about the shortcut a little bit later. It's always the first number times the last number. Goes to the top of it. The bottom number is always the middle. That's not hard at all. There's multiplication. There's no real math in that yet. We're going to have to work a little bit. The second step says add up and see the bottom. Some people love and some people hate. I think it's kind of like one of those like logic puzzles or brain teasers. We need two numbers. Those two numbers multiplied to the top and add up to the bottom. First, we're going to put those on the left. There's the negatives. I'll talk about this today. We want two numbers that multiply to the top, add up to the bottom. Once we do that, we're going to set up a place where the two numbers that we got right here, boxes, and we the first number. At least we'll reduce fractions, and then we'll do that bottoms up step. That's why it's called slide bottoms up. It's from those last things, but obviously, other than the bottoms up, I don't really know where the divided slide is. Okay, that probably makes no sense. Don't worry, we'll do an example. So, the first step, I take my x, so I put an x over here. Don't be scared to make it a little bit bigger rather than a little bit smaller. And in the top of that x is my first number times my last number, 5 times 12. Now, you don't actually have to write out 5 times 12 on a test or a quiz. However, on your notes, I would, just so you know where these numbers are coming from. The bottom number is 19. Now, this because some of you guys, and I'm 100% jealous of you, and you're better at this than me. It's the jealousy. You can look at this and say, oh, the two numbers are this number and this number. They multiply to 60, they add up to 19, that was an easy one. I can't do that. I have to have a methodical process. If you can, by all means, you can skip this next part. But for me, I needed to go through and actually try, or else, like I said, I'm not going to ever get it. So this is where I do just like we did earlier. I put a little bracket with 60, and I just list all the pairs that multiply to be 60. All those factor pairs we talked about earlier. So I have 1 and 60, 2 and 30, it doesn't. Hey, if you need to, always definitely take time to put in your calculator. 5 should work. Oh, I missed 3. That's why you order. 3 and 20. There we go. 4 and 15. 5 and 12, I think. Yep, 5 and 12. 6 and 10, obviously. Then 7. Again, if you're not sure at all, if there's only any percent of doubt, 60 divided by 7, decimal. 60 divided by 8. I wasn't sure. I put in my calculator. 60 divided by 9 gets you a decimal. 60 divided by 10, we're back to 10, so we're done. 3, 4, 5, 6. Doesn't work, 8 doesn't work, 9 doesn't work, 10 does, but we're back to a problem we have already. We don't. We don't have to try 11. We don't have to try 14. We don't have to try 18. Once we're back to 10, we're good. So now go through this list because we need a factor pair. So these are all, I guess I'll tell you, let's take a step back. Step 2 says we need two numbers that multiply to be the top and that add up to be the bottom. So what I did is I just listed all the pairs that multiply to be the top. So those are all the pairs that multiply to be 60. So now we need one of those pairs that add up to be 19. So they all multiply to be 60, so we're good. Go through and look for 19. That's going to be this 4 and 15. Now, some of you guys are going to be tempted to skip that step with the X, and as long as you show your work, I can live with that. This X, and the reason I still do it is because this double check. Put in your calculator is what I would do. 4 times 15 is 60. You're good. 4 plus 15 is 19. I even when I make an answer key, I put those in my calculator. I've seen people accidentally use like 5 and 12, and it doesn't make sense. Take the time, put in your calculator. That's the perfect place to check your work. That we have step 3. We have x plus 4 and x plus 15, but we divide both of those by 5. So that number in front, that A, we divide both of them by that number. And that's, if you look up, like I said, that's step 3 here. We have those 2 boxes, and we divide both of them by the number in front. Now, the next thing you're going to do, if possible, you're going to reduce your fractions. X plus 4 over 5 doesn't reduce, so it just stays that way. 15 divided by 5 is 3, so reduce the fractions. And the last step, whatever fractions you have left, the denominator goes up to the top in front. Take that 5, and that goes in front, so we have 5x, plus 4, so we took the 5 away. 3 in the denominator, so we can leave it like that. Now again, I know this seems like it takes some time, but it's not too bad, especially once you get going with this. Once you get in the groove of this, it goes pretty quickly. Questions right away before we move on. Now again, I know there's a lot going on, but again, this is one of those things, and I know you're tired of hearing me say this. With this problem, there's not a ton of math that goes into it. Yes, technically there is a ton of math going on right now, but really all we did is we found numbers that multiplied to be 60, and we reduced the fraction. Other than that, all the rest of it we just had to set up, and we had to know what order that all goes in. So let's go on to number 4. 4, I have 3 times 12 goes on top, so that is 36. My number bottom, now this is where you have to be careful, and this is where people miss this. 100%. The hardest part of these problems, life would be good, which is the same about your attitude. That's all. Just write that down in your diary tonight. Negative 20. So we need 2 numbers that multiply to be 36. It has to be negative 20. Don't do it any different. It's going to be a negative. We'll talk about that in a second. So I'm looking for factors of 36. So factors of 36 are 1 and 36, 2 and 18, 3 and 12, 4 and 9. 5 doesn't work. 36 divided by 5 doesn't work. 6 does, 6 times 6, and we're already at 6. We have it down twice. So again, we already have a number that's on the right-hand side. We already have one we've already plugged in, so we're done. We don't have to try 7 or 8. Here's the problem, though. If you look at this list, none of those add up to be negative 20. But closely, one of them adds up to be positive 20. Right here adds up to be positive 20. That's not what we want. We want negative 20. So here's the key. If you ever have factors and they add up to something close to what you want. Now, when I say close, I don't mean like they add up to be 90. To be positive 20 or to be 100, negative 100. Negative 10 instead of positive 10. If you're ever so close, the only difference is a negative sign. All you have to do is keep that 2 and 18 and switch their signs, both of them. So 2 turns to a negative, 18 turns to a negative. Now notice what I didn't change anything else about our problem. So what I mean by that is 2 times 18 is 36. That's good. Negative 2 times negative 18 is also still positive 36. So we didn't change anything with that. We changed it to give us a negative 20, so that's what we want. So we have negative 2 and negative 18, and this is why I tell you to go ahead and double check. Negative 2 times negative 18, put it in your calculator. It is positive 36, and negative 2 plus negative 18 is negative 20. If you take 5 extra seconds to do that calculator, you will do better on these tests and quizzes, I assure you. It's over. We go through and write this down. I have x minus 2 and x minus 18. It doesn't matter what order you go in. I can switch the negative 2 and the negative 18. them by my number in front, so divide both by 3 and reduce. If you can, this one, the first one can't reduce. The second one by 36. And then take your whatever's in the you put in front. So we have 3x minus 2 and x minus 6. And again, the hardest part about that, and maybe you don't believe me, maybe it's not because maybe you're still getting used to it, but once you do these, you get used to it. The hardest part's the negatives, 100%. And I will tell you, the negatives are going to get a little bit harder in a second. Move on to the next one, I'll tell you, just a really small, quick tip. The number in front, you have an A term or you have a leading coefficient, what they call that. Then at least one of your binomials down here is going to have a number in front. This one only had 1, that one had 3 in front. Some of them, both of them have a number in front. But if you have a number in front of your quadratic, then you will at least have a number in front of one of your binomials. It could be both, but at least one of them. And if you do everything I tell you to, you don't have to worry about that at all. But it's a good way to double check. Any questions before we move on? Now it's going to be where it gets, I mean, I would say, but not terrible. It just comes down to knowing your signs. My x. 4 times negative 15, sorry, can't write small. Still does. That's okay. 4 times negative 15, if you put that here, don't forget the negative, negative 60. And then we want factors of negative have to be negative 4. So again, just like I said earlier, make sure you keep track of your negatives. Negative 15 is in the numerator, negative 4 is in the denominator. So we do everything normally, just like from before. Factors of negative 60, not positive 60, negative. One thing you'll notice, and I'll still go over this one, but one thing you'll notice when you do a worksheet or a test, sometimes this happens where we already did 60 up here. To reinvent the wheel, if you just want to copy you could. Already done 60. I'll go through it again. But just FYI, if you ever notice that, it's a good little shortcut if you think of it. Factors of 60. So here, don't work too far ahead unless you do this. Just like we did earlier, 1 times 60 is 60. But here's the difference. Earlier we wanted 60. Now I don't want 60. I want negative 60. So what I do, I always put the negative with the left-hand side. Now that doesn't mean that's right. That's just a starting point. That might be wrong. I maybe should have put it with the right-hand side. But just to stay consistent, I'm putting with the left-hand side, and I'm sticking with that. I'll tell you, we can talk about how to change that in a second. So negative 2 and 30, negative 3 and 20, negative 4 and 15, negative 5 and 12, and negative 6 and 10. And we're looking for the ones that add up to be negative 4. Which one of these add up to be negative 4? Well, here's the deal. None of them do. But if you remember what I just told you in the last one, any of them add up to negative 4, but we do have one down here that adds up to be positive 4. We're really close, just the sign, just like I told you on the last one. If that's the case, all you need to do is take both of those and change both of their signs. Instead of negative 6, we're going to make that into a positive 6. Instead of positive 10, I'm going to make it into a negative 10. Now, I'll check. That's still everything we need. 6 times negative 10 is still negative 60, so we're sitting here with that. Everything's fine. They add up to be negative 4, positive 6, and negative 10. Earlier when I told you, I always just put the negatives with the left-hand side just to stay consistent. I said I might be wrong. This one, should have put all the negatives with the right-hand side. For me, it's pretty easy to realize that difference and then switch them when I need to. Sometimes it's the other way. You put the negative with the right-hand side, sometimes they're up there too. Some people that get pretty good at this can tell which way to put it, but I'm not going to go over that because I don't want to confuse anybody. So, once you have double check, positive 6 times negative 10. Put it in your calculator. That is negative 60. Again, the thing you'll see a lot is people that have negative 6 and positive 10. And if they just take that 5 seconds to double check, they catch their mistake. So that's the main reason I like this X factoring. It's a check. That's the hard part. The rest, we have X plus 10, X plus 6, and X minus 10. Both of them by 4. They say fun, but I like it. Both of them reduce now. So before, only one of them did. So 6 divided by 4, or 6 over 4, is 3 over 2. You divide both of them by 2. Negative 10 over 4 is negative 5 over 2. Again, both by 2. We just reduce those fractions. Just like we normally do. Those numbers go up, so we have 2x plus 3 and 2x minus 5. So that one, again, we got two fractions, but we just reduce both of them, and then if we have any denominators, we put those in front with the x. That gets rid of that fraction. Okay. So far, so good. Any questions? No, if you haven't ever done this before, there's a lot coming at you. I'm hoping you guys kind of remember this from Algebra 1, even if you did it differently. I hope you kind of remember some of the basics, and then this is one of the few places in math. I will never say this is easy, but I genuinely think the hardest part is those dang negatives. And that's school appropriate. By myself on the weekend, definitely more severe. So number 6, same thing. We have our x, 2 times negative 9 goes in the top. So that's negative 18. And then we have positive 3 in the denominator. Or sorry, in the bottom of the x, it's not a denominator, it's not a fraction. So, same thing. I need factors of negative 18, and I want those to add up to positive 3. So I do the same thing I did before. I always just put my negative with the left-hand side. So I have 1 and 18. 2 and 9. Again, I make the 2 negative because it's negative 18. Negative 3 and 6. 4 doesn't work. 5 doesn't work. 6 works, but we're back to where we already have problems. So we're done. Which one of those adds up to be positive 3? Well, now this one's kind of nice. This adds up to positive 3. We don't have to change any signs on this one. Negative 3 plus 6 is positive 3. If you would have tried to go, put all the negatives with the left, if you would have done that on the right side, the right-hand side, you'd have to switch something, but that's okay. Like I said, I just always put them with the left. That gives you a good starting point. So we have negative 3 and positive 6. And again, I can't stress enough. Again, it only, you could tell me. Negative 3 times 6 is negative 18. Negative 3 plus 6 is positive 3. Done. Doesn't take very long. X minus 3 and x plus 6. Both of those by 2. Now reduce. The first one doesn't reduce at all. The second one reduces down to just 3. It's kind of nice. So the fraction, put the denominator up with your x, 2x minus 3, and x plus 3. Last thing I'll say before we move on to one other thing. Remember, you can also, so I told you it only takes a couple seconds, maybe 5 is an exaggeration. It only takes a couple seconds to check your work with x. To check your work, which is a lot more concrete and definitely works better, but it takes way longer. You can always multiply these out. times 2x, 2x times -5, 3 times 2x, 3 times -5, minor like terms, you should get your answer. So you can always double check that way. Okay. Last but not least, pay attention to your signs. I guess I should say. Of help is to pay. Another way to check your work is pay attention to the signs. When I was in school, I remember they taught me look at the signs, and you either add them together to get the middle number, or subtract them to get the middle number, and then the bigger number got. It was really confusing. So in my opinion, I like this X factoring better because you don't have to worry about what is what. You just have to pay attention to positives and negatives. If you want to help yourself a little bit, a couple different things. So this second sign, if it's a plus, that means both your signs are going to be the same. Here. So both these signs, if that was a plus, both of them are going to be the same. If sign, right, you see if it's minus, that means they're going to be different. So this one's different. So if I scroll up, you can definitely see that was a minus. This one's different, so that's definitely a minus. So number 5 and 6, that sign is a minus. If I look up a little bit more then to the other ones, this one's a plus, which means both your signs are going to be the same. Little thing, if you want to, if they're both going to be the same, your first sign. So this one, they're both going to be the same. They're both going to be minus. The common mistake on this lesson is if you have a negative here, a lot of people put a positive and a negative. No, this plus means they're both the same. They're both going to be minus. That is just a really quick way to check your work. I'm not giving you that on a test or a quiz. Well, I'm not giving you that on the test because you don't need that. If you do it the way I'm telling you, you don't have to worry about any of that. It'll all work out. Okay, here's the deal. We have about 10 minutes left. Make you guys do these on your own. I would rather you guys do your worksheets. The X, it probably isn't open yet, right? My apologies. Give me 1 second. I will open that. If that ever happens, if you tell me, I won't be offended. I'll either say, yeah, it's not open for a reason. I'll probably be aggressive about it. Try to make you feel bad about yourself. I'm just kidding. That won't happen. Almost. This is about the time where the internet usually crashes. There we go. Almost. We're going. Going good. Getting there. Hey. Sign. Should be good. Maybe. Suspense. It's like when you're waiting for your toast to pop up. Oh! Also, fun fact, if you thought that conversation was riveting, I'm also still recording.